I was given these earrings as a gift. I love them because they match this bracelet. The person told me that they were brand new, but I'm a little suspicious because there's rust on them. Rusting happens slowly, so these earrings must be older. How fast a chemical reaction happens is called a rate. The study of chemical reaction rates is called chemical kinetics. Some reactions take a while, like rusting. Other reactions, like the combustion of gasoline in a car engine, happen rapidly. Today we're going to explore some factors that affect reaction rates. This is Real Chem. We have some ground up iron, some coarse, and some fine grained. These can react with oxygen to form iron oxide, what we usually just call rust. There is a bunch of oxygen in the air around me, so let's heat this iron up and get this reaction going. Now we'll try this with finer ground iron. This increased its surface area available to react with oxygen. Now we'll try this with an even finer grained iron. This increases surface area available to react with oxygen. It reacts much faster. Subdividing a solid into smaller particles increases the rate at which it reacts. We can use an iodine clock reaction to explore reaction rates. It's easy to tell when the reaction is complete because the color changes. Here we have one beaker filled with an iodate solution and another filled with a bisulfite solution. Let's mix them together and see how long it takes for something to happen. The color change makes a great finish line to this chemical race. Now what happens to the rate of this reaction when we change the concentration of one of our reactants? This solution has double the concentration of iodate compared to this one. Let's add our bisulfite. When we doubled the concentration, we doubled how quickly the reaction occurred, its reaction rate. In general, if you increase the starting concentrations, you increase the reaction rate. We now know the surface area and concentration can affect reaction rate. What about other factors, like temperature? I know when it's cold outside, I'm not as fast as when it's a beautiful sunny day. Let's look at the effect of temperature on reaction rate. I have iodate and bisulfite solutions that we kept on ice. We will test how quickly this cold one reacts compared to the one at room temperature. As you can see, the cold reaction went way slower than the room temperature one. In general, reactions are slower at lower temperatures and faster at higher ones. Here I have some hydrogen peroxide, the stuff you might use to bleach your hair. Hydrogen peroxide is always decomposed into oxygen and water. In this cylinder, I have put some soap, which will capture the oxygen being created. It's not very exciting though, because it's a very slow reaction. But what happens if we add some potassium iodide? 3, 2, 1. The potassium iodide we added is a catalyst for this reaction. A catalyst speeds up a reaction without being used. When this chemical reaction is done, all of the hydrogen peroxide has turned into water and oxygen. We still have our leftover potassium iodide. Okay, let's recap. We have identified 4 factors that affect the rate of a chemical reaction. Increasing the state of subdivision makes a reaction go faster. Increasing the concentration of reactant makes a reaction go faster. Increasing the temperature makes a reaction go faster. And adding an appropriate catalyst makes a reaction go faster. And that's Real Chem.